What is up, YouTube? Welcome back to another episode of How to Geometry. In this video, we're going to go over some polygons in the coordinate planes. So we're going to be given some coordinates that make a quadrilateral, and we're going to run some tests to see exactly what kind of quadrilateral they are. Either a parallelogram, rhombus, rectangle, trapezoid, or square. So let's get it. All right, polygons in the coordinate plane. The idea is that we're going to be given some quadrilateral. All right, parallelogram, rhombus, rectangle, trapezoid, something of that nature. Its vertices are going to be coordinates, right? An XY coordinate. And we're going to have to verify certain aspects, either lengths of sides being congruent or the slopes of sides. Either they're going to be the same slopes or they're going to be perpendicular. Some key formulas is the distance formula, midpoint formula, and the slope formula. Slope formula is rise over run. Now given a picture, it's more efficient to count rise over run, the slope, and then analyze what that number is, as opposed to doing the calculations. Now, if you don't have a picture, you're definitely going to have to use the slope formula. Just keep that in mind. Okay. Some couple reminders is that parallel lines, if lines are parallel, then their slopes are the same. And perpendicular lines have slopes that are opposite reciprocals. For example, if the slope of one line is -2/1, then the opposite reciprocal would be 1/2, meaning the second line, or these lines, would be perpendicular to one another. Okay, so the first example we're going to look at is classifying this triangle in the coordinate plane. So we want to prove that triangle ABC with these coordinates is an isosceles right triangle. So for an isosceles, we need to show that two sides are congruent, right? Because that's the definition of isosceles. Then we want to show that it's a right triangle. I want to show that two sides are perpendicular, meaning that they meet at a right angle, 90 degrees. So to do that, we'll show that two lines are perpendicular. Now, it doesn't matter where we start. So here is the picture. Here are the points they were given above. All right, the first thing I want to do is find the distance of one of the lines. So I'm going to do, again, it doesn't matter where you start. I'm just starting wherever. So I'm going to figure out, let's calculate the length of AC. So by doing that, we're using the distance formula. Right, distance formula right here. The square root and the difference in the x's squared plus the difference in y squared. So feel free to pause the video and work this out for yourself. But 1 minus 4 squared plus 3 minus -1 squared. Okay, 1 minus 4 is -3. And 3 plus -1, or 3 minus -1, is really 3 plus 1. 3 plus 1 is 4. And again, that's squared. So this is going to be the square root of 3 squared, which is 9, plus 16. Right, 4 squared is 16. And this is the square root of 25, which we all know is 5. So the length of AC is 5. All right, so let's figure, what is the length of CB, line segment CB? Again, here's the equation. but it's difference in x's squared, so 5 minus 1 squared plus 6 minus 3 squared. 5 minus 1 is 4. 6 minus 3 is 3. So it's going to be 4 squared plus 3 squared. Again, 4 squared is 16. 3 squared is 9. Square root of 25. And we see that it's 5. So a statement that we can make is that we know that we just proved that AC is congruent to line segment CB. All right, so this is a pretty important statement. All right, that proves the first thing we wanted, that two sides are congruent. So AC is congruent to CB. All right, next thing I want to show is that the slopes. So when you're drawing these out, right, you kind of got to have some intuition, right? You kind of look at it and you can kind of tell, like, okay, I can see about where the right angle would be. But let's verify that it is in fact a right angle. So I want the slope of AC. So AC. So the way I do it, I count. So I'm going to go from C to A, right? The most left point, and I always either go up or down, and then I always go to the right no matter what. So I'm going to start at C, and because we're going down, it's going to be negative. So negative 1, 2, 3, 4. So negative 4 to the right, 1, 2, 3. Down 4 over 3. So down 4 over 3. So negative 3/4. CB, again, I'm starting at C and I'm counting up, so positive 1, 2, 3, and then to the right 1, 2, 3, 4. So 3 over 4. Positive 3 over 4. Now when we analyze the two numbers, negative 4 over 3, positive 3 over 4, so they are opposite reciprocals. And this means that they are perpendicular. So now we can say line segment AC is perpendicular to line segment CB. So here's the second statement we want to prove, or that we wanted to show. These two statements are sufficient, are enough to say that. So you may or may not have seen this before. So 3 dots represents the word therefore. It's a mathematical symbol for therefore. Therefore, ABC is an isosceles triangle. Actually, right triangle. And there's our concluding statement. Right, so the highlighted part is what we're verifying. The work is kind of the answer. But we wanted to verify the two things, and we did. And then, therefore, we can conclude that it is an isosceles right triangle. Okay, next example. Proving that a quadrilateral is a trapezoid. So if you think about the definition of a trapezoid, is that it has exactly one pair of parallel sides. So that's what we need to show. That's what we need to verify. So here we have the given coordinates, KATE. And we want to show that there's exactly one pair of parallel sides. So let's look at the slopes of all the sides. So first, the slope of KE. So KE is the vertical line. So vertical lines have a slope that we call undefined. It's undefined. It's a U. Okay. The slope of AT, so So AT starting from A going down to T. So it's going to be negative 1, 2, 3, 4. To the right, 1, 2, 3. So negative 4, 3. All right, the slope of KA. Starting at K going up towards A. So up 1, 2. To the right, 1, 2, 3. So positive 2 over 3. Positive 2 over 3. And then lastly, the slope of line segment ET. So from E up to T. So I'm going to go up 1, 2, 3, 4. So positive 4. And then to the right, 1, 2, 3, 4, 5, 6. So 4 over 6, which reduces basically 2 over 3. So notice, comparing all the slopes, there's exactly 2 that are congruent. So this shows that one pair is parallel. So KA is parallel to ET. So therefore, KT is a trapezoid. Right, here's my evidence and then my concluding statement. All right, next. Proving that a quadrilateral is a parallelogram. Okay. Here we are given LMNO with the given vertices, their coordinates, and we want to show that it's a parallelogram. So I know at a glance, we see it, and I was like, yeah, it looks like one, but we have to verify it. So by definition, a parallelogram has 2 pairs of opposite sides that are parallel. So if I can show that the opposite sides have the same slope, and both sets of opposite sides have the same slope, then that's enough for proving that this is a parallelogram. Now you may notice there are multiple ways of figuring this out. So whichever way you decide, stick with that, right? I'm only going to show the one method, but there are multiple methods. So there's no need to show all the methods. You just got to show one of the methods. And I'm only going to show you one. So the method we're using is to show that both pairs of opposite sides are parallel. I think that's the most straightforward. So when you look at LM and ON, right? LM and ON are horizontal lines, right? And horizontal lines have slope of 0. LM has a slope of 0, ON has a slope of 0 because LM is horizontal and so is ON. Therefore, LM and ON both have slopes that are 0 and are parallel. So slope of LM is 0 and segment ON, slope of ON is 0. Therefore, LM is parallel to ON. All right, looking at LO and MN. So starting with O going up to L, so positive 1, 2, 3, 4, 5. So 5 over 1, 2. So 5 over 2. That's the slope of OL. In segment NM, 1, 2, 3, 4, 5. And to the right, 1, 2. Again, 5 over 2. So both of the slopes of both of these lines are 5 over 2. So the slope of OL is 5 over 2. Segment NM, the slope is 5 over 2. Therefore, OL is parallel to NM. And we can make our concluding statement. In conclusion, so therefore, LMNO is a parallelogram. Is a LMNO is a parallelogram. That's what we wanted to show. So now, there are other methods. You could show that the diagonals bisect each other. That would require using the midpoint formula. You could show that both pairs of opposite sides are congruent, so the distance formula. Or you could show that at least one pair of opposite sides is both parallel and congruent. So you'd use the slope and the distance formula. So whatever method you decide, so you can pause the video and try to work out the other three and see which ones you like better. I personally like the first method, especially if there's a picture, because you can just count, right? We all like counting. All right, so let's prove that a quadrilateral is a rectangle. So GHIJ, with the given coordinates, is a rectangle. So again, there are a couple different methods. I'm only going to show one. So if we can show that the diagonals are congruent, then this would be enough to show that this is a rectangle. So again, we want to show that the diagonals, so JH and IG are congruent, right? The diagonals, that's what we want to show. So we're going to do the distance formula on both of these. So again, I want to show that JH is congruent to IG. So when I take the distance of JH, again, the square root of the difference in x's squared plus the difference in y squared. So this is going to be square root 5 minus 0 is 5 squared plus 3 minus 3, which is 0. That's nice. Squared. So 5 squared is 25. And the square root of 25 is 5. So JH, the length is 5. 5 units. Okay, so now let's look at IG. So line segment IG. So again, the square root of the difference in x's. So 1 minus 4 squared plus 1 minus 5. So 1 minus 4 is negative 3. So the square root of negative 3 squared plus 1 minus 5, which is negative 4. So negative 4 squared. So we're going to get 9 plus 16, which is root 25. And again, the square root of 25 is 5. So here we showed exactly what we wanted, that JH is congruent to IG. So we can make a statement that so IG is congruent to JH. Therefore GHIJ is a rectangle. So the second method of showing that a quadrilateral is a rectangle, you could show that a pair of adjacent sides form a right angle. So this one requires a little bit more work, right? You'd have to show that there's 4 right angles, that all adjacent sides form or a pair of adjacent sides rather form a right angle. All right, I did method 1. I think it's sufficient. Okay, proving that a quadrilateral is a rhombus. So given the quadrilateral ABCD with the given coordinates, we want to show that it's a rhombus. So again, there's multiple methods. I'm just going to show the one. Here, we want to show that the diagonals are perpendicular. So if the diagonals are perpendicular, meaning that they have opposite reciprocal slopes, then that's enough to show that this is a rhombus. So BD, AC, and we want to show that they meet at a right angle. So let's count. If we count the slopes, so if I go from let's start with BD. So starting at B going down to D, so negative, negative 1, 2, 3, and to the right 1. So negative 3 over 1. So the slope of BD is negative 3 over 1. Or just negative 3 rather, however you want to look at it. But negative 3 over 1, that's the slope. All right, next, let's show that AC is perpendicular by counting the slope. So starting at A and counting up, so positive 1, 2, 3 to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 3 over 9, positive 3 over 9. So positive 3 over 9, which reduces to 1 over 3. So then we do a quick little analysis of the numbers. All right, we're always analyzing. And we see that, are they opposite reciprocals? Yes, they are. So this means segment BD is congruent to AC. Therefore, ABCD is a rhombus. Okay, proving a quadrilateral is a square. So given ABCD with given coordinates, we want to show that it's a square. All right, so the idea is that we're going to apply the 3 methods that we just looked at to one problem. So if I can show that this quadrilateral is a parallelogram by showing that the opposite sides are parallel, and if I can show that it's a rhombus, that the diagonals are perpendicular, and also that it's a rectangle, that the diagonals are congruent, then we can conclude that this shape is a square. So it's going to be analyzing the diagonals. So BD and AC. So first, let's look at, are the opposite sides parallel? So AD, we're going to look at the slope of AD. So starting at A, counting down, 1, 2, 3, 4, 5. Actually, it's 4. 4, down 4, so negative 4, and to the right, 1, 2, 3. So down 4 over 3. So the slope of AD is negative 4 over 3. All right, the opposite side, BC, starting at B and counting down, we have 1, 2, 3, 4. To the right, 1, 2, 1, 2, 3. So down 4 to the right 3. Down 4 to the right 3. So here we have that segment AD is parallel to segment BC. All right. Then the slope of AB, right? Opposite sides have to be parallel. So AB, so starting at A, we're going to count up. 1, 2, 3. Then to the right, 1, 2, 3, 4. So up 3 over 4 for AB. And then DC, we're going to start at D and count up. 1, 2, 3. To the right, 1, 2, 3, 4. So 3 over 4 as well. And we see here that AB and DC are parallel. So these two statements we can conclude, therefore, ABCD is a parallelogram. Okay, next I'm going to show that the diagonals are congruent, that they're the same length. So that AC is the same length as BD. So feel free to pause the video and work ahead. All right, so the length of AC, 7 minus 0 squared plus negative 1 minus 0 squared. So the square root of 7 squared plus negative 1 squared. So this is 49 plus 1. So root 50. I'm not going to simplify it. I'm just going to leave it at that. Root 50. That's how long it is. AC. All right. BD is 3 minus 4 squared plus negative 4 minus 3 squared. So this is going to be 3 minus 4, which is negative 1. And negative 3, or negative 4 minus 3, negative 7. So we're squaring both of these numbers. So negative 1 squared plus negative 7 squared. So 1 plus 49. Which is the square root of 50. Again, it matches. So here we can show or conclude that segment AC is congruent to segment BD, and therefore ABCD is a rectangle. All right, and the last thing we want to show is that it's a rhombus, that the diagonals are perpendicular and that they meet at a right angle. All right, so looking at AC, starting at A, counting down, so negative 1, and then to the right, 2, 3, 4, 5, 6, 7. So 1, negative 1 over 7, negative 1 over 7. So negative 1 over 7. The slope of BD, so starting at D, counting up, so positive 1, 2, 3, 4, 5, 6, 7. To the right 1. So 7 over 1. Positive 7 over 1. So looking, they are opposite reciprocals. Right, negative 7 and then positive 7. So here we can say that AC is perpendicular to BD. Therefore, ABCD is a rhombus. Now, because we showed these three facts, it's a parallelogram, it's a rectangle, and a rhombus, we can finally conclude, in conclusion, that ABCD is a square. Okay, so hopefully this video helps out a little bit. Just remember, you want to apply the method correctly, right? So it means drawing the picture and looking at the picture and kind of getting an idea of like what sides you're going to look at, what angles you're going to look at, what diagonals you're going to look at. And always draw a picture, even if there is no grid. Just try to draw one the best you can. And then, or at least get the ideas together of which line segments you want to run through the formulas. So it's plug in the formulas even if you don't have a picture. All right, so if you haven't done so already, please subscribe, like this video, comment, let me know down below what you think, and I will respond. All right, till next time, peace.